Hey everybody. So I've been using Microsoft 3D Builder for a little while, and I use Blender and a few other things, but Microsoft 3D Builder is a good starting point. It's a lot like Tinkercad, but there seems to be a lack of information on how to use it out there. So I thought maybe I'd just do a little bit of talking about how to get into it and what to watch for and stuff, as I have an Alexander Keith's. So it's kind of a building blocks type of a 3D builder, which is very different from, say, Blender, which is more of an extraction type of a workflow. So you cannot save your project till you add at least one cube. So let's add one cube. And then let's save it. And then so 0, 0 is basically, if you look at this, this is where things will appear on your bed of your printer. So try and keep it above 0, 0 on both sides. And then that'll make it easier when you actually, if you import your 3MF, or is it a 3MF? I can't remember what they call this format. A lot of time they hide it. Properties. 3MF, yeah, it's called 3MF. So this is like the 3D manufacturing format anyway. This is what Microsoft uses. So you're going to need to take this cube and you're going to need to scale it to a part of what you're trying to build. So try and look at what you're building in terms of geometrical shapes. So, take your object, measure it. So I'm going to measure the face of this object at 58.5. So I'm going to want my Z height to be 58.5. And then I'm going to pull that up so it's on top. And then the width on it, this is long, measure my measuring tape, is 24, so 240 millimeters. Oops. And you see there, we'll undo that. I didn't have it in. I need 240 millimeters. And then I will move that to, now what I'm creating is actually 3 millimeters thick. We'll give it a Y of 3 millimeters. So what I'm creating here is actually a little cubby hole, because what I'm doing is in my 1993 Sierra, I'm tearing out 3 large components and replacing them with an Android stereo. I've already created the upper, and I'm trying to create just a cubby hole to fill in the lower part that I can put stuff in, just to kind of give the inside of the truck a finished look. So I can take this object and if I go to object mode, I can duplicate it. I've duplicated it and I can move it back. And then And incidentally, I was snapping on. That's in the settings. Where's my measuring tape? So I can make this cubby hole 120 millimeters deep, and you can see by this one is highlighted. It'll tell you which one it is. 120 millimeters deep, and 50 millimeters tall, which is the z-axis, and that's going to stay centered, incidentally, when I do that. It's a little bit different of a workflow from using Blender in those, but I like it. It's quick for making fast stuff. So we're looking at 236 for length. And that will keep that centered on this object because I duplicated it from that object. So so what are my dimensions here? And look, I can just snap that up against that, and I have, so that is basically a representation of the, almost a representation of the equalizer that's in a 93 GM pickup in the center, down kind of in the center of the dash down there, and cassette deck. Probably no guess there as to why I'm getting rid of the cassette deck. There's no cassettes anymore. There's no such thing. Now this cassette deck has, sticking out the back of it, a spike that helps to hold it in place and align it. So I'm going to create that spike by going 25. So I need to create a cylinder that is 25 in height, and I'm going to rotate it. Now if you've got snapping on it, if you rotate out here, you can rotate to any angle, but if you go in here and inside of the arrow and rotate, it will snap. So I'm snapping it to 90 degrees. That's a handy little thing to use. Now let's move it back here. Now it is dead centered in this area. And the equalizer. The equalizer is 236. And that is 118, 236. That's halfway. So it is centered in the back of the stereo. Now because I have snapping on, I should be able to move this across and get it to snap. You'll feel it kind of snap in the center. Now, what's the diameter of this? Now I have a caliper that I use for this. So I'm going to caliper it, and it is 9.58. We'll just use 9.5. It'll be a good enough fit. So we'll go to this and we'll say 9.5 by 9.5. Now, what's the offset from the bottom? So there's a couple ways you could do you can either offset the center of it, or you can offset the offset from the bottom. And it looks like offsetting the center of the bottom is like 3.5 millimeters. So I'm going to actually bring another cube in here And I'm going to use it only for spacing. And I'm going to make it 3.5 centimeters tall. And I'm going to use the snapping to snap it to the bottom. I'm going to slide it over, snap it to the center, and then I'm going to let go of it. And then I'm going to slide this down on top of it. And look at that. My 9.5. Now, there is kind of a little point to this spike on the end that helps to align it into the hole. So, I was wondering if maybe I could take insert a cone. Take the cone, spin it 90 degrees. I don't know if you'd call this the missing manual, but anyways, let's go to dimensions. Let's make this 9.5 by 9.5. Now, interestingly, Z is not Z anymore as soon as I rotate that. On circles, it does that. It tends to keep it. Let's get this centered. Let's let it snap to center. Let's move it down till it snaps to that height. Then let's move it in. Now let's measure the overall length of this out from the unit. It is 32. Is it 32? Oh, we'll use 31. Being slightly short probably won't hurt. So let's make this 31. We can use it for reference. You see that the green arrows show up. That's the one it's currently on. Let's make that 31. And then let's snap it up against the back. That's our length. Now, we're going to eyeball this last little bit here. What the hell? So we got so that's 25 out to there. Let's move this out for a sec. Let's move this out and let's make it 20. It's 25 in length. So let's. Okay, so here's some big time things too to think of while you're doing this. I am not merging anything as I'm going. I am not subtracting anything as I'm going. I'm just trying to block out the shape. Is mostly what I'm doing here. And then I'm going to, so I've got my reference shape here of how long I want this to be after the cone. I've measured the length of how straight it is before it starts to become a cone. Now I'm going to actually just take this piece and I'm going to drag this one to get somewhat of an acceptable curvature on what the point is. Of how pointy this alignment peg is. A little bit not enough is probably okay. So let's leave it at that, and then let's take this object and let's go to the edit and let's no, not reduction. I wanted to split it. So let's spin the splitter. See, if I'm out here, I can go any angle. But if I go inside, it'll snap to your 90s and your 45s and your 60s and your round numbers, right? Then I can get a good perspective view here and drag this in till it's that length. Then I can split it, and you notice when I was splitting it, I had it on keep that piece only. You can keep both pieces if you want to. Sometimes that's advantageous, but I want to completely get rid of that. So watch this. So this is the piece and this piece. I'll highlight both of those, and I will join them because that's my peg. Then let's paint them in the, let's use gray as a final color. So that piece is done. That alignment peg is in the right place on the back of the equalizer to what it was on the equalizer. I'm not. So this piece is just a measurement piece. It's a cube. We'll just put it to the side for now. And the other thing that we have on this is some tabs. So we have some tabs that help us to, so this, let's take this and this, and let's paint them silver because these are going to be final pieces. But let's we can deselect that here or on the thing. Sometimes it's easier to deselect over here. But let's take this piece and then let's object duplicate it. Now we can use this piece afterwards to cut out of it. So we're just going to set it to the side right now. But we can look at it and we can say, okay, so based upon this width, it's 236. Let's go with 3 millimeter thick wall. So 3 millimeter on both sides is 6 millimeters. So let's change this to 230, and it will remain centered. And then up and down, our up and down dimensions on it are 50 here. So let's subtract, do 3 millimeter walls again. So we're looking at 6 millimeters off of that is 46. And this one remains centered. And now when we insert that back into there, we are going to get 3 millimeter walls all the way around. So let's pull that back out. And then let's just leave that for now. We're going to use that to cut a hole in it afterwards. Actually, let's cut a hole in it right now. So we can take this piece and this piece, and let's group them. And I mean, we can group this piece too, because that's part of our final. So that's our final thing, right? But we're trying to make a cubby hole in here. So let's make this, let's paint it into, let's make it translucent, and let's make it white, because white works good as a translucent color. Now let's take this piece and let's put it in here and see what it looks like. That goes right to the back, does it? It doesn't go right to the back. Oh yeah, because snapping it to the front. So that gives us a 3 millimeter back wall, because this piece was 3 millimeters and that piece was based on the length of this only. So we have it the right length. To have a 3 millimeter back wall. 3 millimeter back wall should be good. However, we want it to cut through the front. So let's just stretch out the front a little bit to an arbitrary amount by pulling it. And that will leave that aligned, and that'll leave all of that aligned. And then we can go to the edit and we can subtract. Look at that. So it cut it gray inside, but let's let's choose all this and let's paint and make it all, it's going to be black in the end. Let's make it black. So this is the cubby we've created in not very much time for putting in a 93 GMC pickup truck. However, it's not quite done yet because it needs some tabs to, whoops, I knocked my solder down. We need some tabs to put onto it to bolt into the truck. So this cube is 3 millimeters, and we're going to want this to be 3 millimeters. So let's rotate that. Come on, snap it to 90. Pull it up, pull it over. Okay, then let's insert another cube. I use other cubes to measure lots of times. It works pretty good because you can snap right to the side of them. Then I'll take a measurement tape or a caliper and I will figure out how far over it needs to be. And it looks like it needs to be over 46 from the edge. So I'm going to make this 46 wide. Now there are 2 tabs on the top of this unit for bolting it in. Snap down to the top. Now, what's the offset back? Ooh, these got an angle to them. Angles can be tricky. 19. We'll go with 19 to start with. And then we'll snap that to the front of the unit because that's where I measured from. And what's the height? The height is 21. And then we will snap that to where I measured from, which is the top edge. No, undo that. I just wanted to click it to deselect it. So we want this, and we want it to be 22 wide. And let's slide it over, slap it against that, move it back, slap it against the back. Actually, before we do that, let's get it the right height. Our height was, what? What was our height? Our height was 21. No, not that piece. Get rid of that piece. Which one's the right one? Oh, a Y. Because we've rotated that piece. We want that 21. And let's slide that down. Let's slide it back. Now we're going to want some, we're also going to want that to be duplicate that, and then let's freaking, no, not, well, whatever. Let's rotate it to, that's a bad angle for that. I can't, let's just go 90 manually. Sometimes it's easier to do manually depending on the angle. And then we want to have it equal with the back of that. And we want to slam it up against that block. It's a little bit too wide that way. Let's figure out approximately what we want. What is it? It's about 20, is it? Is it 20? Reach 19.5. Let's slide it back, see what happens. Sticks at the back a bit. I don't think that'll hurt anything when it bolts up. I'm gonna have to trim that anyways because it's a weird angle. Okay, so and then I'm going to spin this way. I'm going to duplicate that, and then I'm going to slide it to the other side. Now I'm actually going to duplicate that again. Then I'm going to, no, not the right way. Let's undo to make that. I want this one because I want to put it to 0 that way. Then I want to slide it down, slide it over, slide it down to there. Now, because there's a little bit of a gap there, and it would actually make it solider to not have that gap there, I'm actually going to change this to 4, and then I'll slide that down. There's still a little bit of a gap. I'll change it to 5, and then I will slide that down. Now there's a bit of an angle on this bloody thing, so I'm going to figure out what that angle is by going simply by measuring how far away it is. 15.5. Give me the angle? No, 16. I think 16 gives me the angle. So I'm actually going to make this piece 16, and then I'm going to slide it all the way to the front, and then I'm going to take this, unselect that, select that, and I'm actually going to rotate it. Stop it. Actually, before I do that, the hole straight through it or through it on an angle? The holes are straight through it. So before I do that, I'm going to figure out how far the hole is down from the top, and it's centered. So I'm going to say, so it's caliper says it is centered at 10. Where's 10 too much? 10's too much. It's centered at 9.5. Centered at 9.5. So I'm going to insert another little cube that I'm going to make 9.5 tall. And I'm going to use it for a spacer, a measurer. Why does that not look right? I'm not sure. Let's double check the measurement. because it's the center. Because it's the center of the hole. So 9.5 is the center of the hole. So what I'm doing is taking advantage of the snapping. Then I'm going to take the cylinder, I'm going to rotate it 90 degrees, and I'm going to make it the size of my hole, which is 5 millimeters. Five mils. And I mean, this is going to be a hole used for cutting, so like 10 is fine for length on it. And I will get it up here, and I will pull it over here and get it to snap to the middle. And then I will get it to butt up against that as best I can. And then I will move it back so it's sticking through. And then I'm going to subtract. And then I'll take this piece and I'll just move it right out of there because I don't need it. Okay, so I've cut that hole. Oh, I did that wrong. Because I need it in the middle of that. I need it in the middle of that. Then I need to get this thing the hell out of the way. And you take this, and then I need to subtract it. Then I need to get that angle on that based on that's pretty close. Maybe a little less angle. That's pretty close. Then let's get this freaking reference piece out of here. So we have, let's take this piece and this piece, let's group them. And then let's split them because we don't need that extra material. We're going to keep the bottom split. Isn't that pretty? And then we need that piece, and then we'll group those. Well, actually, let's ungroup those. Deselect the bottom one and group those. And take the bottom one, and it's obviously not quite wide enough. So that looks like 22 is our magic number. Let's snap that into place. I don't think those angles might hurt. Okay, so I think I probably need to, judging on by this, I probably need to group that, and then I need to run a split on it and shave it. Shave the whole thing to match that angle. Come on, give me that. split that. And now we've got a nice angle all the way along there. Then we can take that, and we can take that object and duplicate it. And move it along. And let's take a measurement of how far it is from the other end. The other hole is 29, so it's 30, 29.75. 30 is a little much. Let's do 29.75. So let's deselect that. Let's take this. Let's make it 29.75 long. And let's use it to measure from this end. And then let's take this and snap it up against it. And then let's deselect that and get this measurement device out of there. And now, the second hole is oblong. So let's take another cylinder. We were 5 and 5. And we'll like that's quite arbitrary because we're using it to cut. Let's roll it over. And let's move it up. Let's slide her down. Get it centered in there. Okay, well, we're having trouble getting it centered in there, but let's try to move it in closer, see what we can do. See if we can get it a little bit better. Okay, there we go. Now it's snapped into place. Now the problem we have with this hole is an oblong hole, and it is 5 millimeters tall and about 8 long. So to duplicate that, we will get our X and go 8. 8. No, not 83, 8. 8 by 5. That gives us our oblong hole. Now there was a little bit of a... Now I'm going to try and center this in this piece just because it doesn't want to at all. Because there's a little bit of a slant to this, if you remember. No, not that way. Undo. Try and grab this. No. Undo. I want this one. No. Undo. Why does it keep you doing the sideways one? I want it to do the up-down one. Fuck you. There. It's not going to be perfect, but it doesn't have to be perfect. And then let's, we've got that in place. Edit. Subtract that hole. There. Now we've got an oblong hole on one end and a good hole on the other end, just like our equalizer. So now we can take this, let's deselect everything else, take this and this, and we will delete them, and look at this. So let's take that and that, let's paint them black. Now that we're right at the end, let's group it all together. And look at that, we have a cubby hole that will fit where the equalizer used to be in a 1993 GMC Sierra. It will bolt right in, hopefully. It will follow the alignment peg and bolt right in. So let's take that right at the end here. Let's merge all of that. Now, because I use mostly squares, if you'll see here, If you go to view and go to wireframe, it can be very helpful to show you how many polygon faces there are. Now, if you're doing a lot of stuff with curves and irregular shapes, this is all triangles and squares. If you're doing a lot of stuff that doesn't have so many triangles and squares, one thing that really helps is if you go to Edit and go to Simplify and reduce your face count, especially before you do subtractions and merges. Because, I mean, a lot of times you don't need something perfect, right? Like, look at this. Do I really need this? Look at all these vertexes. Do I really need this resolution on this hole? No, I need a hole there that is basically oval. I could have done a reduction before I subtracted and saved my computer a lot of computational power. And you'll notice that I waited right till the very, very end to do the merge. So use grouping of objects rather than subtractions and additions as much as possible. Do your subtractions and the additions right at the end, but don't do them until you've gone through every last object that you've made and put them at the minimum resolution you need them at. You'll just save yourself so much frustration. If you neglect to do those steps, you can actually just end up just stalling out your computer. It'll look like it's doing nothing, and that's very frustrating. The other thing is, before you can pull this directly into Cura without converting it. You can export it as an STL. I'm going to cancel this because I don't need to reduce the faces. It's fine. It's decent resolution. It's fine. It'll look all right when it's put in. So you can put a 3MF into Cura with no problem. Or if you want to put it into STL, you can save it as, change this to an STL or an OBJ or whatever you want. But Cura will pull in 3MFs. So we're going to save this. You can save it here too if you want. And the only other thing is, before you pull it into Cura, is if you put it to 0, 0 here, 0, 0, 0, make all the zeros positive. It'll make it easier because Cura won't pull it in a weird level and stuff. So we've got this saved. So now we can open up Cura, Ultimaker Cura. And then let's I'll put it on my other screen. I will pull the lower into Cura. So see, it pulls it in at 0, 0. And usually all you have to do is say edit, arrange models, and it will put it in the center. Now, with what we're looking at right here, do we want it to do all the support to hold that? No. So our orientation is interesting here. We have an orientation problem because it's going to want to do infill all underneath here, all underneath there, and all inside of it. So we need to think about what we want for good faces and all this kind of stuff. So if we put it on its butt, what happens? So let's select the object and let's put it on its ass. And you'll see it moved it up. Now there's going to be basically support done on all the red areas here. I don't know if there's a very easy way to get around this with this object because of the way it's printed. unless I take off the alignment peg. What's the easy way to do this? The easy way to do it might be to take off that alignment peg and then screw it on after to avoid all that. But mind you, how much is that really? If it supports the entire thing. I think it's less than putting it on the other sides and having it support all the other. Yeah, I think I'm going to just go with it like this. And then let's slice it, see what happens. There's going to be a lot of wasted filament here, and then wasted filament of the rim around here and underneath here. But what's our 4 days to print this? We might be able to save like a lot of filament by trimming this into pieces. And so what if we take this object and we I haven't used the, you know what, so let's clear the build plate. Let's put that down. Let's open up the lower again. Now let's take this and let's take this and let's, if we split it right here and then glue that on after it's done printing, that could be just beautiful. The other thing to do would make some alignment pegs and stuff, but check this out. So let's take the object, let's edit it, let's select that, and let's split it. We can go exactly 90 degrees. Keep both. And we can move this till try and get it just right. Split it, and then watch this. We'll take, I've got two pieces now. We'll take this piece, we'll rotate it to there, then we'll move it over and down for now. This piece, we will take it and we will rotate it to there. Then we'll lift it up to there. Then I will save it like that. And then we'll close that. And then we'll open Cura again. I just minimized it, I left it open. And we will take, oh, nope, not the upper, the lower. I'm already printing the upper. See, it kind of did the pieces wonky. I don't know where the other piece is. There we go. But the Range All Models pulled it in. Let's take this piece, move it down. There we go, it falls onto the build plate once you get it close enough. Other than being really freaking high, it was decent. So look at, now the red is dramatically lower. So now watch this. Let's slice this again. See what happens. Two days from 4 days. And we reduced our filament significantly. And all we have to do after is take some glue and epoxy or glue and glue the back onto it, which is going to be so far back that nobody's going to even know if it's glued on or it was printed all as one piece. So we're going to save that to disk because our SD card we're going to use is in the printer right now, printing the upper. Truck radio. So that is our little bin that's going to replace the equalizer. In the dash of a Chevy Silverado that looks like this. But damn it, just show me the pictures. So this right here is, see, they just got a tape deck with a cubby hole. Mine has an equalizer all the way across. So I'm replacing, this is the piece we just made, was the piece for here. It's going to be a cubby that goes all the way across and fills that whole hole in. The upper I made removes this. This is a weird stereo. They've got a piece here, and a piece under the dash. This is the head, this is the FM AM receiver, and then this is the equalizer tape deck. So I'm replacing the equalizer tape deck with a cubby to put stuff in, and I am replacing the upper with basically an adapter that puts an Android piece in there, and I'm replacing the piece under here with nothing, and it's going to be wired in. So I designed and 3D printed a piece that adapts this to allow the Android piece to go in. And it's just a $60 Android deck. It sounds good. I had it going in the house here. It really, it allows you to blend with, sync to your phone and everything, and you can put flash cards in. A 32 gig flash card will have every song you can think of in it. It'll play movies and everything, so I mean, it's quite an upgrade for an old truck like this. But yeah, so but the whole point of this is to give you an idea of how you go about using something as simple as a Microsoft 3D Builder, which is a free product, to create stuff. Because there's a lot of information that's lacking out there. When you start to use it, you'll wonder why you're running out of resources and why this, why that. Like if you look here, it's like, see, that's just going to be filled with a cubby for stuff. Quite interesting, eh? This guy's got his dash all apart. Oh, it's a little excessive. But I'm putting it right up in here. Right up in here. It'll hang out to the side a little bit. I've made it so it'll sit out a little bit and it'll hang out to the side, which I'm hoping won't interfere too much with my automatic transmission. But if it does, it does, whatever. And then here's just going to be a cubby hole. Lovely. Anyways, that's all for today, you guys. Have a good day. Thanks for hanging out. Bye.